Welcome to the presentation that we prepare for the system in cold climates. This presentation regards what you have to take in consideration when we speak about installation in cold climates, and in particular we are going to focus on what we as Ammonit recommend for both the sensor and power supply to be used. You can maybe ask why you should go to Ammonit for projects that take place in cold climates. That is mostly because we have a lot of experience with this type of installation. In the last years, we deliver regularly systems where we have a complicated sensor with heating and different voltage levels. And we can support both experienced partners that have already made many projects in this type of field, but also brand new partners or customers that have no idea, firstly, how to approach this type of project and need suggestions. We have our office in Berlin, and here we can provide you also with the cabling, the cabinets that will be all produced in Germany, so in Berlin specifically. And with our data logger, we can also provide you the monitoring and the checking of your project once installed using, for example, our software platform Ammonitor. When we speak about the climate or cold climates, that is what is in this picture is shown is what we are talking about. So is an environment that is usually difficult to approach. You need to plan any visit on site. Probably there is not a main road available. You are isolated, and also for your power supply, probably you not have a grid connection close by. So there are many things that you have actually to take in check when approaching this type of project. What first you should, of course, take in consideration is the fact that in this type of environment, the temperature will be lower than the usual type of mass installation we are all used to. And this brings the fact that, of course, your sensor can be iced, but also completely freezed. Plus, the snow presence can also make your measurement not reliable and so not usable for your own campaign. In this type of environment, there is, of course, less solar radiation available due to the snow, to the clouds, and all these must be considered in the moment that you plan, for example, to use a solar power supply, and also in the moment that you have a lot of sensors that, for example, have to be heated, and with less solar radiation available, probably your option to the power supply will switch to any other source of supply. Also, you have also to take in consideration that the visit on site will be limited in time, so you want to be sure that once you go there, you are go in specific case and for specific handling of problems. This is a picture that shows actually the effect on snow for different time frames for an anemometer. What happens is that you can have a little sedimentation, let's say. So you can have a sensor that have a little amount of snow and ice on its caps. And this usually happens when the snow is there for a short period of time. But you can also have, like the last picture of this slide shows, you can have a sensor completely blocked by ice and snow. These two extremes are pretty easy to be detected, and also the data that they deliver are pretty clear for your campaign to be detected or dismissed. In the first case, you have still reliable data, but in the last one, you have actually no data at all. The situation is more complicated for all the other time steps because, of course, here the snow and the ice affect your measurement, the measurement of your sensor. But this is difficult to figure out without seeing the sensor live on site. And these are the situations that we want to avoid at most, because these are situations where your measurement is not reliable, but your sensor is still measuring on site. So for making this possible, so to avoid this type of situation, we recommend, of course, to use a sensor with incorporated heating. In particular, according to the type of mast that you are going to use, if it's for monitoring or for assessment, there are different solutions. For example, here you have a sensor with a little roof above his terminations, where the measurement is going to take, and this protect the measurement. Or like on the right side of the slide, you have a sensor that has heating not only in his arms but also in the shaft. And this, as you see, allows the sensor to continually providing reliable measurement even when the situation around is pretty there. We at Ammonit, we recommend mostly TS sensor for this type of cold environment. We have a lot of experience with the ultrasonic anemometer, in particular the 2D and 3D. There are also specific settings from TS regarding the 2D, this upside down configuration, and for any other measurement mast or installation that has to be provided, we can also provide a compact solution and weather station. Mostly, as I said, we work with ultrasonic anemometer from TIS, and this is mostly because these sensors are classified according to the latest IEC norms. They present the possibility of having different voltage supply, as it shows in this slide. This allows us and our partners to be able to configure their mast and their power supply as best possible, and according also the option available on site. As I said, the 2D has the possibility to have an upside down montage that allows the snow to not be posed on the transmitters, but on the boom of the mast, so saving the measurement from any influence of the snow. For the 3D, there is also the possibility of measure the Obukhov length and also the vertical component of the wind. Usually we have both these model on stock, ready for you to order them and deliver on your side. So this reduces the time that you have to wait before planning your installation on site. Here we are showing some extract of the calibration protocol that we usually perform for the 2D and the 3D. From this slide, you can see that both sensors are, the performance of both sensors is pretty independent from the external temperature where they are being used in, and also that the 2D has an effect on the sensitivity, on the yaw sensitivity, mostly due to the fact that, of course, there is a back zone. So there is a zone in the back of the arms where, of course, the measurement cannot be so precise as it is in front of that. And this is completely not present for the 3D, as these two figure on the left shows you. One question that we are asked often is the difference between the internal heating of the TS sensor mostly and the audio function. The internal heating is an aspect that many TS sensor has and is an internal regulation which cannot be controlled from the outside of the sensor. So there is a temperature sensor inside each heated sensor, which automatically switch on and off the heating according to the measured external temperature. In case of TS, most of the time this temperature click in at around 5 degrees and it's switched off at 8 degrees. This allows this sensor to have the superface, the external superface, free of ice. And this is a solution that, as I said, cannot be controlled from the outside. It is not programmable. The IDO function is a particular configuration that is present only in the ultrasonic anemometer and is a free pin on the sensor that can be configured both as an input but also an output and can receive both signals, so an analog or a digital signal. By us, we have developed a configuration that we use this pin as an input, and we connected this to our data logger through a switch, and using a 5-volt signal, we say to the ultrasonic in question, please turn your heating on or off according to the customer desire. Here you see a representation of the system that we usually use with our Meteor 42, which is connected to a switch, and this switch goes first to the ultrasonic using this ADIO function. And for complicated installation where also other sensors are being heated, like anemometer or wind vanes, we can connect in parallel more switches so that with one command you can turn on and off the heating of your complete system. And this of course allows you to both activate the heating even in condition where usually it should not be activated, but also to turn it off in condition where he is on, but you want, for example, to save power supply and you don't want the heating to run too long. One thing that we recently have implemented also for our data logger is the reading and the possibility for the customer to know which TS status by is currently running or was running in a specific moment for your ultrasonic. This is a telegram or is actually a register which is present in all the ultrasonic anemometer that can be read and interpreted. Here you have an example in this extraction picture that we took from our monitor of an ultrasonic status by. Here is indicated with the blue line, while the red one is the temperature of the environment. And here you can see that the status byte has different values, so it's constant firstly at around 200, then has some sudden back or fall back, and then it is again on 200 plus or minus. Here you can see what this register means, so 204 and 206 are values that say the heating is on because the criterion are met, so that is a condition where the heating should be on, but this low fall that you see correspond to the register 14, which means that the heating criterion were not met anymore in this specific period of time. That's why in this period of time the heating was not on. And this is an instrument that can help a lot handling your ultrasonic. Overall, if there are like malfunctions or you figure out that your system is consuming a lot more than expected and you don't know why, probably it's because the heating of your ultrasonic is on more than you have planned to originally. And with this view and with this register reading, you can easily figure out all these event that happens to your installation. As I said, by Ammonit, we provide also cabling for these cold climate environments and installation. Generally speaking, we use a solution with junction boxes, mostly because the sensor from TS but also from other manufacturers always comes with a specific plug that cannot be changed, and thicker cables that are required in this type of installation, mostly for the voltage loss along the cables, cannot be soldered in these plugs. So the junction box is a solution that allows us to use larger cable, thicker cable, but still being able to connect to the sensor in question without major damage to the sensor itself. Here you have a picture of a standard junction box cable that we provide. The sensor is connected using a short cable to the junction box, and in the junction box the cable is divided in two. One part in this case is Modbus communication, so RS485 cable with this termination too. And the second part is the heating. And here, as you can see, we can use different type of cable. They are all manufactured by us in Berlin. And this cable then is connected to the cabinet of the data logger. This is a pretty standard solution nowadays, so we have provided many of these cables in the past years. We can also provide more complicated cables. In this case, now that I'm showing, you have actually 4 anemometer FCA-X that are connected to our data logger, but with 2 outputs and with heating. So we have the RS485 connection, we have the Counta connection, and in this case, for this junction box, also 2 separate heating. This is usually separated because if one of the two lost, let's say, the connection to the supply cabinet, the other one can still run. And in this case, we are speaking of 2 top anemometers, which are connected to the following junction box, where the third anemometer is installed a bit lower. And finally, the last one. So in this project, you have a very complicated cable with 3 junction boxes, 2 outputs, and heating, and 4 heating separated. Finally, until now we spoke about sensor. For what regards the power supply, of course, you have to take in consideration that in cold climates, you are gonna use probably more heating, and for maybe more sensor. This has an impact on the general power consumption of your system. Here we showed you for reference some values using Meteo 32, but also anemometers, and then another sensor, but then also 1 ultrasonic anemometer, 2 ultrasonic, and then also a system at 48 volt DC. As you see, the power supply the power consumption really changes. So we need to correct estimate the consumption for then dimensioning in the right way the power supply. Due to this, you will probably not use a standalone system, but maybe you prefer to connect your system to the grid, or using a trailer that has maybe ethanol. Of course, these are all options that we discuss with our customer, also according to their availability, I would say. A thing that we recommend to do is that whatever power supplying is being used, a monitoring of this should also be put in consideration, because this is already give a sign that maybe a visit on site is required. Overall, if there is not backup support, we always recommend to use a backup power supply in case the main has any issue. With a backup, you are always sure that at least your measurement is always constantly running. But without a backup, if your main power supply for any reasons works no more, your complete measurement is gone. Another thing that of course we recommend is to use a device that consume the possible available on the market, like for example modems, but also data logger, and that is why the Meteo 42 with its two solution Mars and Kex come in play, because it allows you of course to save a lot of supply. And also we have recently developed and improved the logic controller in the Meteo 42 with its switch, the new switch manager. This is gonna be explained more in detail in another lesson, which I recommend you to go and check. But for you, it's important to know is that with Meteo 42 you can configure more switches and so also regulate and be able to approach and change stuff of your system. So you want to turn the heating, for example, of only one sensor instead of two, or you have an alarm installed. All of these will be possible now with the logic controller. Thank you.